Matrixes-QOTD.
Am I recording? Oh, I am. Okay, welcome to another episode of QOTD Further Pure Mathematics. Who are we with today?
Are we supposed to introduce ourselves?
Oh, yes, you are.
Raymond, go first. Are we supposed to be energetic?
Bro, just say it.
I'm Raymond.
Raymond is the blue one. And we also have Kwanha, which is the anonymous one. So Kwanha is the learner, and me and Raymond are the teacher. And as you can probably see from the title, we'll be teaching you further pure mathematics. And in today's lesson, we'll be going through the very first chapter, unit, / topic. And it will be on matrices.
Why is this like
Exactly. And so we'll be going through what is a matrix, order of matrices, square and unit matrices, zero matrices, and basic matrices calculations. And last, we'll be going through commutativity and associativity of matrices. Okay, so let's start it off. What is a matrix, Raymond, Professor Raymond? Let's see where he is. He is over here.
So, yeah. A matrix is this funny-looking guy.
And he is drawing a matrix indeed, and I will explain whilst he draw. So a matrix is essentially a bold capital letter representing a set of numbers or data, and we can see the number is covered by square brackets, and we have a bold capitalized letter indicating the matrix, and we have columns and rows. I probably drew it the wrong way, but then you know what I mean. And they consist of individual cells which contains the element of that matrix. And Raymond, tell us something about the order of matrices.
So for this particular matrix, you can see there's 3 rows and 3 columns. So we can say the order of this matrix is 3 by 3.
Order is 3 by 3.
You know how you usually describe box sizes, TV sizes? Wait, no, okay, whatever. It's the same thing.
Okay, screen resolution.
So, for example, let's go to the right.
Bro, I just followed you.
Transition.
Bro, you are edging me so. Okay, now we have a new matrix N, and it is 2, 3, 2, 5. Okay, 3, 5. Some very uneven brackets.
We defined. Let me just.
Yes, sir.
We define the order to be saying the amount of rows first, number of rows, and then the number of columns.
Yo, Professor Raymond,
So
I have a very common question. What is a row and what is a column?
Fuck you, go back to Admas.
Gotta sense this part.
What the hell? So N will be a 3 by 2 matrix, whereas, let's say, A, we can see there's 1 row and 3 columns.
Let's
it's a
go.
1 by 3 matrix.
He knows how to count. Impressive.
Yes. Yeah. Boom.
And now we're going to talk
So
about
now hopefully
square
you know
and unit
what is a
matrices.
matrix. Yeah. So for square matrices, pretty obvious by the name that the matrix has to be square. And what do we know about squares? Is that their lengths are equal.
Exactly.
And in matrices, what the fuck? The sides, the base and the height is equal. Yes. Yeah. Huh. So in the context of matrices, it will be the number of rows equal the number of columns.
Tick.
In this case, this is a 2 by 2 matrix, where we can also say it's a 2 by 2
square
matrix.
Now onto
Yes,
unit matrices.
You can get out, go back. You can expand this further into 3 by 3 or 4 by 4 square matrices. Yeah, I'm too lazy.
Very good handwriting.
A unit matrix, very fun word. Can also say it's an identity matrix. Is where the ones lie. Okay, the one lie on the diagonal and everything else is 0. You'll later learn why this is called a unit matrix.
Yes, sir. Later we'll explain the significance of unit matrices.
Usually we denote the unit matrix with a
I, yes.
Don't know
Italic
why,
I.
but like, maybe it's special. You are my special.
Dun, 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 dun.
Now, there's a final special name for another type of matrix. We denote it by a bold O, where every element of the matrix is just 0, where we call this a 0 matrix. Now, 0 matrix can be of any order, like 3 by 16 billion.
Exactly. And now onto matrices calculations.
Yeah. Let's go somewhere fun.
Like somewhere fun.
Let's say we have matrix A. Must be in bold. Pretend it's bold.
Exactly. And matrix B.
And let's say we have matrix B. Oh, he knows.
Okay, I'm gonna use a blue
You can say
pen.
the order of matrix A is 2 by 2, and matrix B is 2 by 2. They are of the same order. And when two matrices are of the same order, you can say they are conformable for matrix addition. Are you the scriber?
I'm scriber, yes.
Also, conformable is with an N. Do not mix up with comfort. Comfort.
That was so close to getting us banned. Okay, so
in this case, A plus B. Oh, what the? You add each of the
cells.
elements of their corresponding positions into their corresponding position. Okay,
So it's just like
oh my. No, you need to do working out.
Okay, I'm sorry, boss. I'm sorry, boss.
Let's see. We can see the top left is 3 and 9. So the top left of when A plus B will be 3 plus 9. Yes. Same applies to 5, 7 is 5 plus 7.
So it's basically vectors.
It's not vectors.
It's not vectors.
So basically.
Because why? Quick pop quiz, guys. Dun 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 dun. Why are matrices not vectors?
Vectors are matrices.
Well done, Eric. You skipped the question.
Oh wow.
Matrices
So,
can be vectors.
Matrices are not vectors because vectors are specifically of only one column.
It can be like infinity
And
down
you
for
could
infinite
say-
dimensions.
So you can technically describe that there are an n by 1 matrix where n is the amount of dimension the vector has.
Yes.
But a vector is very specific and describes something else, like an arrow in
So
the
vectors-
Cartesian plane.
So vectors.
But a matrix usually describes a transformation. You'll later learn how matrices affect transformations.
Oh, so basically, like.
Subasa, we're in the middle of a video.
Die.
Okay, so the one who just joined sounds really sleepy is Subasa, the fourth member of QOTD, the sleeper.
And the final member.
Yes.
Don't say
Later
final,
we'll
like,
explain the
That
difference.
sounds like all 3 of us is gonna die in a boss battle and he's the final.
No. Okay, and what is associativity and commutativity, which is the very last topic
No,
we're gonna talk about?
Before that, Eric,
I'm so
don't
sorry.
be so eager
I'm gonna kick
to
you.
move forward. We need to cover all topics.
I'm gonna kick you.
For a matrix, let's say 3, 7, 2, 5. You can also multiply it by a scalar, which is just a number in front that scales things. And when you do a scalar multiplication for a matrix, you do same idea, the position, right? 3 times 3 is for the top left, it's 9. 3 times 7 is for the top right, 21. Apply the same. Yes.
Essentially, you just do it for each of the cell.
Yeah. Think of like multiplying into the bracket, except the bracket is much more fancier.
Okay, sure.
Oh, what the?
Now we're gonna talk about associativity and commutativity.
Okay, Eric, you need to get to this part because you just roll ass and calm.
Why are we doing? Why is this happening?
It's okay, I'll post this video because I had zero viewer.
We'll talk about associativity.
Which is just
This is when the order of doing operations do not matter.
Exactly.
This is the statement, you can write it in your book.
This is when you have a LeBron James plus a Kobe, you get nothing. Because LeBron and Kobe, they're both captains. And they never pass.
What?
Okay, now let's go back to math.
Let's say you have 1 plus 3 plus 2. No matter which order, if you do 1 plus 3 first, or 3 plus 2 first, you'll always obtain the same result, which is 6. So we can say addition, an operation in mathematics, is associative. This is what associativity is. Later you'll learn what kind of matrix transformations are associative.
Exactly. All will be in further lessons. If you like this, please leave a like, subscribe, and hit that follow button.
What is this? This is self-advertisement.
I mean, follow button and subscribe is the same thing on YouTube.
But like, go on Instagram. Although we don't have an Instagram account, but go on there.
You told them to hit it 2 times. They're gonna unsubscribe.
Okay. Now we're gonna talk about commutativity.
And then hit that again.
Commutativity.
Okay, let's talk about commutativity. Funny word. Notice how the first part is commute. Commute has is like, I don't know, some word for like togetherness. I don't study Latin or Greek. I mean, I do on Duolingo for like a 1-day streak of studying Greek. So, if commute means together, it implies that if you swap around the order of things,
It don't matter.
you still obtain the same result.
It don't matter.
So let's look. 1 plus 2. Is it the same as 2 plus 1? Definitely. What about 2 times 3? Is it the same as 3 times 2? Definitely. What about 3 divided by 5? Is it equal to 5 over 3?
Yes!
No. Get out. So we can say addition and multiplication is commutative, but division is not.
That's so sad.
Yeah. Okay, let's talk about my Greek lesson.
No. Okay, so that's all for today. Hope you liked it, and we'll follow up with more matrices lessons in the future. And leave a subscribe.
Wait, what is